once again live, and once again seeing if I can get contacts on 80s. Did what I got yesterday, which was 3 contacts while running just 200 milliwatts from a 1 transistor transmitter, a fluke. Well, today I'll try a bit more power. I'm using 2 transistors like I started with yesterday, but this time hopefully without the final transistor blowing up. Fingers crossed anyway. I'm on 80 meters. I'm using the VK3YE web SDR, and I'll just give you a sample of the signal. So as you can hear, a bit of fading, but a bit more power should make the signal a bit more robust. So anyway, we'll call CQ and see what happens. I don't think conditions are quite as good as they were last night, but I'm running 10 times the power. Let's better feel the transistors, and yeah, not getting warm, so I think that's a bit better. And there's a couple of comments. So hello to Chris, Foster's, and Matthew. And great that you're ordering the QCX. Never tried one myself, but apparently, there seem to be good reports on them. So yeah. Now, if you're not hearing me directly, I'm on 80 meters. One of the web SDRs that you'll be able to hear me on is VK3YE. So have a turn around when I'm calling and you'll be able to hear me on that. Another one that's very sensitive is VK5ARG. That is like about 600 kilometers away from me, but it can hear me very well pretty much all the time. And hello to Joan. And oh, it's Sunday night. This is 20 people, 19 people watching. So, yeah. Oh, well, I suppose hopefully there's something. Mustn't be much on TV. So it's 21 people, so very good. And hello to Tom. Well, anyway, I'll put another call. Good to have you watching there, Tom. Might get a bit of paper for something. And if you've just turned on, I'm just running about 2 watts on 80 meters CW, and see if I can get any contact. So similar format to last night. Probably won't go as long tonight, but I'm running a bit more power because the transmitter is behaving itself and the transistors are not getting hot. And hello to Ive, Pioneer 50, Gordon, and Sunday morning in Europe. And hello to W3OJ. Right. Might do some drawing. Now, can I send CW while drawing circuit? Probably not. Yeah. All right, for those who've just joined, I'm calling CQ on 80 meters, just using a 2-transistor homebrew transmitter, uses a ceramic resonator for 3.58 megahertz, and that can cover pretty much the entire CW end of 80 meters. And hello to Eco9786 and Kiwi SDR in Croydon. Yep, that's the one I'm also using. So yeah, that's about 50 kilometers or so away. And hello to K0WPC. And John Ward, my antenna is a G5RV up at about 10 meters at the apex. And hello to Brazil and ON Land as well. Yeah, just 3 and 2.2. And hello to IV3MIR. Yeah, it's funny. It's sometimes you can get a response straight away. Like this afternoon, I was using the Hoxie on 40 meters, crystal control, put out one call, and I got a response from PK5GG Graham. So thanks for that, Graham. And yeah, had a good contact there. Tonight's taking a bit longer, despite running more power than I was last night. Anyway, we'll keep going. All right, my drawing has produced a circuit, so I'll show you the circuit. Before I say much, I'll just hold it still for a while. And okay, going from left to right. Right on the left is a ceramic resonator oscillator using a BC548 transistor, could be a 2N3904. And On the far left is a variable capacitor. I've got it as 10 to 200 picofarad, not that critical, but that gives you a good frequency adjustment range with the 3.58 meg ceramic resonator that I'm using. You could use a crystal, but then you'll only get maybe a kilohertz frequency shift. Moving further up, a couple of capacitors around the transistor. It's a Colpitts oscillator circuit. In series with the emitter is a 100 ohm resistor. It's just marked 100 there. And the keying shorts it to earth, turning on the oscillator. So it is a keyed oscillator. And with a keyed oscillator, you are more prone to have a bit of chirp than if you're keying another stage. But I don't think this one sounds too bad, so I've got the keyed oscillator. And the LED just on the left, that provides a constant voltage, sort of like a voltage regulator. The Xenon diode almost probably about 2 volts. It's a red LED, and the idea came straight off. In fact, this circuit came, a lot of it came off a transmitter called transceiver called the Reggie, and that was designed by AA1TJ. I built it for 40. I have built 1 or 2 of them, and it worked first time. So that's the circuit that I've adopted, although the other parts of the circuit are different because I've only got it as a transmitter, not as a receiver. The Reggie circuit managed to do everything in just 1 transistor. And it put out about 100 milliwatts on 80 meters. With the 1 transistor on its own, I could get about 200 milliwatts. So I was running it a little bit harder, and it was actually getting quite warm. Now, in the collector, you've got 10-turn primary and 4-turn secondary. Now, that's just some enameled copper wire on a binocular toroid. It's a ferrite toroid. You could just use a lifesaver type toroid like an FT50-43. That would be okay. The type that I'm using has 2 holes. It's like about 2 by 2 centimeters, bit under 1 centimeter thick. It's a binocular toroid type thing, and sometimes in TV antenna balloons and broadband transformers, whatever. Anyway, I don't think that matters very much. The important thing is that it's ferrite, and so you've got a primary of 10 turns and a secondary of 4 turns, and that provides a impedance step down because the base of the transistor is a lower impedance than the oscillator. If you want to cut back the power output, you could put a resistor from across the base of the second transistor, and that is a BD139. I found it wasn't needed, but if there's some spurious oscillation or anything, then yep, you can calm it down with a resistor. Use something like anywhere between 10 ohm and maybe 100 ohm, depending on how severely you want to throttle things back. In the emitter circuit, I've got a 12 ohm resistor in parallel with 100 nanofarad. That is, I just use that to, again, throttle things back. You could possibly try shorting the emitter to ground. Then you definitely would need a heatsink on the transistor, which I still haven't got. In the collector circuit I've just written 10 turns. It's actually on a ferrite toroid. Could again be a FT50-43, 43 being the type of material, the F meaning it's ferrite, and the T I think just stands for toroid, and the 50 means it's 0.5 of an inch in diameter. So if you see a toroid that's like T68-2, then there's no F, so it's not ferrite. In this case, it's iron powder. 68 means it's 0.68 of an inch in diameter, so it's a bit bigger. And the 2 is the type of material, and that's normally red. There's another common type of toroid. You might come across something like let's say a T37-6. There's no F, so again, it's iron powder. 37 means it's 0.37 inch in diameter, so about a centimeter, a little bit smaller. And the -6 is a different type of material. That's normally yellow, and that is better at higher frequencies. So if you're building a transmitter for 10 meters or a receiver or something, 28 megahertz, then you probably use a T50-6, whereas on 80 meters or 40 meters, a T50-2, the red type 2 material, it would be fine. And as far as John goes, where do you find your parts? Well, there's various suppliers like I've got lots of bits like Hamfests and junk and bits and pieces. I very rarely need to buy parts, but yeah, there are suppliers around. If you in Australia, there's one called Mini Kits based in South Australia. Have a look at their website. I think it's minikits.com.au. Then there's DigiKey. I don't know if Radio Spares, RS Components, if they're still going in the UK. Farnell, Mouser. Anyway, that's a few names. You might be able to find what you want on eBay, Hamfests and stuff as well. So yeah. Although these are all pretty, in Australia, we've got an outlet called JCar, which is a bit like the Tandy that, or the Radio Shack that you had in the States, but a bit more technical. Anyway, pretty much every part of what you see on this diagram, you can walk into a JCar shop tomorrow and buy. The only exception is the ceramic resonator, and there are some suppliers around for that. So that's the circuit, a 2-transistor transmitter, puts out 2 watts, and the box on the right, that is a low-pass filter. And what is the purpose of the 10-turn coil in the BD139 collector? Well, basically it's to sort out RF from the DC going in. It functions as an RF choke, so it supplies power, 12 volts plus 12 volts to the collector of the BD139. But being a coil of a reasonable value, it would be something like 10 microhenry or 22 microhenry. If you've got a fixed coil of that, you could put that in there. Yeah, it stops RF getting out, because even though the top rail that you see at the top of the page, as far as DC goes, it's 12 or 13 volt. As far as RF goes, it's the same as being earthed. You can see there's capacitors across that keep it down at ground potential as far as radio frequencies. So yeah, that's the purpose of the choke. And then there's the you made a circuit. Would you key it to hook up to it? RX, where would you key it? Main thing is you've got to have the oscillator running all the time. But if you've got that, then you have your little capacitor tapping off a bit of RF going into your receiver. So I would personally key it in the emitter, like here of the oscillator. Although you would have a resistor across the key, so that even when the key is up, there's the oscillator is working, possibly at a lower output level than in transmit mode, but you've still got some RF being generated, and that is the local oscillator for the receiver. Anyway, that's the circuit. People say, people will probably comment, where's the circuit? Anyway, the answer is it's right here in this video. So a very simple 2-transistor transmitter. Anyway, I'll go back to calling CQ. Well, the signal's getting a bit stronger. And if you've just joined, I'm calling CQ on 80 meters. If you want to listen in and you can't hear me from where you are, you can use the VK3KHZ with SDR. Oh, there's a contact. VK3DA. Who I worked last night. Say hello to Paul. He's given me a 5 and 9. And hello to Alan. And, well, someone asked a question, but it's all Greek, so I can't understand it, sorry. Or Russian or something. And hello to Leighton, VK3YE. Now is a really good signal. And yeah, okay. Well, that was a contact with Paul VK3DA, who's I think about 20 kilometers from here. The time here is 10 minutes to 10 local, and the side tone. And yes, Lightning Stalker, you're right. It's coming from the FT817. There's a weaker side tone as well that's delayed from the VK3KZ SDR. You know, just in case anyone's listening, it's a good idea once you finish a contact to put out a quick call in case there's anyone still around. So we'll do that. Now, something I haven't checked, I don't think I will, reverse beacon network. Put in your call sign and see if anything. Sometimes if you're running very low power, it doesn't always detect you. Depends on the conditions at the receiving end, but you can still get contacts. We'll try another call. All right, not get anything. Now, I should mention that if you haven't seen it, the video before this explains in a lot more detail this other little rig, which I've called the Poxy. Not the Pixie, but the Poxy. Anyway, this one is 2 transistors, but it's a transceiver. Uses a BD139 for a 7 megahertz crystal controlled transmitter and a BC548 for the receiver, which is quite unusual because it uses a reflex circuit, and that basically functions as RF and audio amplifier, and that gives you 2 transistors worth of gain in just the one transistor. So yeah, really nifty little circuit. Check out my previous video for more detail of this. And yep, it can actually get contacts even with half a watt on 7 megahertz. Oh well, it's I think I'll probably call it a night, but before we do, I'll just disconnect the transmitter and give you a better view of it. Here is the low pass filter, and you can switch between 3 and 7. There's actually 2 little filters in this box, and it's actually you can save a lot of components and even money if you build it as a external unit. So you can just put it in line with your homebrew thing. It's a bit less elegant if you're going to be operating it portable. Hello to Alan, trying to log into the SDR in Araluran. Well, I've now shut down, so I don't think I'll be putting out any more calls. Yeah, been going almost an hour. So this is a low pass filter, really handy. BNC male on that side, BNC female this side. So you just plug this into your transceiver and the antenna into there. Now, for the transmitter itself, bit harder to see all the parts because the circuit board, it's just a bit of printed circuit board material, is all tinned. And this was actually from another project, just the knob from the variable capacitor. And I'll see if you should be able to see the ceramic resonator. It's that blue thing right near the variable capacitor. And then there's the oscillator transistor just there. And you can see the LED. I'll just turn this so you can see the type of inductor. This one there is the one that's in the collector of the oscillator transistor. And it's 10 turns primary, 4 turns secondary. It's on a ferrite. And then the secondary goes to the base of the BD139. This is the final amplifier. And unlike yesterday's effort, it didn't get hot, no heatsink, and it survived. So I think we're on a good thing here. This is the ferrite just in the collector circuit of the final amplifier stage. And I'll just turn it around and give you some different angles of it. Now there's the ceramic resonator. You can see that a bit more clearly. And some of the leads on here are a bit long, probably better if you're building it properly to have them a bit shorter. But this is only 3.5 megahertz. And yep, if you've just joined later on, yes, I did actually make a contact with this probably about 10 or 15 minutes ago. And there's a bit more background earlier in the video. So I'll leave this video up if you want to learn a bit more. And some of my recent videos, I've been just playing around with 1 and 2 transistor transmitters and transceivers. So yeah, watch them as well. And for operating all this sort of stuff, there's various books I've written: minimum QRP, hand-carried QRP antennas, more hand-carried QRP antennas. And if you are getting into amateur radio, if you're a beginner, a couple of other books as well. Australian Ham Radio Handbook, that's if you're in Australia, or Ham Radio Get Started, that's more the American version, because I'm also got the American call sign
VK3YE. How frequently are my live transmissions? Well, Mike, in the last week, they have been really frequent, probably too frequent. I certainly won't be having them this frequent. It's just because I've been playing around with these bits and pieces. Other times it can be months between them. So no fixed schedule. When I'm on, I'm on. When I'm not, I'm not. I'm not one to be keeping skeds or that sort of thing. Because like a couple of months ago, it was quite a while since I last, hadn't touched a soldering iron for ages, and just in the last week, I've been doing quite a bit with this sort of stuff. So yeah, depends on what I've been doing. So yep. So thanks all for watching, and check out my website vk3ye.com and some of my previous videos, as there have been a lot in the last week or so. So yeah, if there are no more questions, I will finish up for tonight. And thanks all for watching.